Hello student, in this lecture we are going to study the geological disasters and control measures. In that we are studying the earthquake. Firstly, what is meant by the earthquake? Earthquake is defined as the vibration induced in the earth crust due to internal and external causes that virtually shake up a part of the crust and all the structures and living and non-living things existing on it. Okay, so the earthquake is capable of causing a several damage to the civil engineering structures. So it is necessary to know that why they are, why they occurs, how they occurs, what kind of harmful effect they will produce. So from the civil engineering point of view, and then also the what precautionary measures can be taken to minimize such a harm and the other related factors. Okay, so this study of the earthquake is very much important from the civil engineering point of view. The earthquake is an also sudden vibrations of the earth surface by the rapid release of the energy. Okay, and this energy is released when two parts of the rock masses move suddenly in relation to each other along the fault. Okay, so here are the figures which showing the damage occurs due to the earthquake. Okay, so in the first figure you can see the buildings are collapsed. Okay, and this is happened due to the earthquake. The people gets frightened, buildings are damaged. In the second figure you can see that the roads are fissured, building are collapsed. Okay, so this loss is occurs due to the earthquake. Our next point is the earthquake terminology. First point is the seismology. Seismology means what? The study or the science which is dealing with the study of the earthquake. Okay, the science which are dealing with the study of the earthquake in all their aspect is called as seismology. Okay, so it is this study is partly geology and partly physics. Okay, seismology is the study of the earthquake, and this seismology includes some part of the geology and some part of the physics also. Okay, so the term seismic is commonly used to qualify anything which is related to the earthquake. Means what? The seismic waves, then seismic intensity, seismic zoning, seismic region. So these all terms are related to the earthquake. Okay, the seismic is a term commonly used to used for the earthquake. Okay, so first our point is in seismology. Second point is the focus. Focus means what? An earthquake is generally due to some disturbance on or the displacement in the rocks and at the some depth below the surface of the earth. The focus in the figure you can see F is indicating the focus. Then focus means what? The place or a point of the origin of an earthquake below the surface of the earth is termed as an focus. Okay, so the earthquake is originated from the point F. Okay, so this is F is indicating the origin of the earthquake, and this point of origin is called as an focus. So the focus signifies a zone rather than the point of the origin. It may lie from the few hundred meters to the hundreds of kilometers below the surface. This focus is lying at few hundred meters to the to the hundreds of kilometers below the surface of the earth. Okay, so this is our second point, that is focus. Then Third point is the epicenter. In the figure you can see E is indicating the epicenter. Epicenter means what? The point or the place on the surface of the earth vertically above the focus is termed as an epicenter. Okay, so epicenter means what? The point which is vertically above the focus. Okay, the point which is lying vertically above the above on the earth surface directly above this focus is termed as an epicenter. So here epicenter in the epicenter the shaking is mostly intense. The intensity gradually decreases outwards. Here the shaking is most intense at the point of the epicenter. Okay, then our third term is the seismic waves. Seismic waves means what? During each earthquake, the elastic waves are generated at the focus. Here in the figure you can see these are the seismic waves. Okay, and these are generated at the point of the focus. Okay, and these waves are called as seismic waves. Okay, so during every earthquake, the seismic waves or the elastic waves are generated at the point of the focus, and these are travel in all the directions. Okay, and these waves are called as seismic waves. Okay, so the seismic waves are of three types. First is an P wave, second is an S wave, and third is as an L wave. Okay, so the seismic waves are of three types. First is an P waves. Okay, so these P waves are called as an primary waves, or we can say also the push or the pull waves. Okay, so P waves is also called as an primary waves or the push or pull waves, longitudinal waves, or also the compressional waves. Okay, so all these are names are for the P waves, and these P waves are the fastest of all the seismic waves. P waves are the fastest waves in all the seismic waves, and they are longitudinal in nature. These P waves are longitudinal in nature. That is what the particles vibrate in the direction of the propagation. P waves are longitudinal in character. They are traveling or propagating. That is, the particles are vibrate in the direction of the propagation. Okay. So next seismic waves is the S waves. S waves are called as secondary waves. Okay, secondary waves are also called as shear waves or the transverse waves. Okay, the S waves are also called as the secondary waves, shear waves, transverse waves, or distortional waves. Okay, all these names are given for the S waves. These S waves are transverse in character. P waves are longitudinal in character, while the S waves are transverse in character. That is, the particles vibrate at the right angles to the direction of the propagation. Okay, so P waves are vibrate in the direction of the propagation, whereas S waves are vibrate in the right angles to the direction of the propagation. Okay, so this is the difference between the P waves and the S waves. Third type of the wave is as an L wave. L waves are also called as a long wave or the surface waves. Okay, P and S waves here. P and S waves are sometimes called as an body waves. All first two waves, that is P waves and S waves, are combinedly called as an body waves because they are traveling deep into the body. Okay, so these both waves, P waves and S waves, are traveling deep into the body of the earth. Okay, so they are called as an body waves. Where the third type of the wave is an air wave, that is these are called as an surface waves because the journey of these air waves is confined mainly to the near surface layers of the earth. Okay, so air waves are called the surface waves because their journey is confined mainly to the near surface layers of the earth. These waves, air waves, are sluggish and recorded only after the arrival of the P and S waves. Okay, so first P waves are reached, then S waves are reached on the earth surface, and then the L waves are reached to the earth surface. The L waves are recorded after the arrival of the P and S waves. These L waves are again divided into two types, relax waves and the love waves. Relax waves means what? The relax waves are the in which the displacement of the particles is of complex nature, partly being in the direction of the propagation and partly at the right angles to it. Okay, the relax waves are their displacement of these relax waves is in complex nature because means what, they are partly in the direction of the propagation and partly at the right angles to it. Okay, these are the relax waves. Whereas the love waves are the here the displacement of these L waves of the particle is particularly horizontal. That is the propagation. That is they are traveling in the direction of the propagation. Okay, so these are the two types of the L waves, that is the surface wave. First, in the seismic wave we have seen the two types of the wave, body waves and the surface wave. P and S waves are combinedly called as body waves, where L waves are called as surface waves. These L waves are of two types, relax waves and the love waves. Okay, so our next point is the isosesmal lines. Isosesmal lines means what? Here is the figure of this isosesmal line. Isosesmal line. In this figure, you can see that these are the lines. Okay, and these lines are connecting the points of equal intensity. Okay, the uh, the intensity is equal on these lines. So these are the lines which are connecting the points of equal intensity on the ground surface are called as isosesmal lines. Okay, if the focus here, if the focus is a point, the isosesmal lines will be a circle. Okay, and but if the focus is commonly a line, the isosesmals are generally elliptical. So from the distribution of the lines, the epicenter of an earthquake can be determined. Okay, so from the distribution of that, here is the lines indicating the intensity of line showing the equal intensity. Okay, so from the distribution of that lines, the epicenter of the earthquake can be determined. Okay, then our next point is the seismographs. Seismographs means what? The seismographs are the instruments which detect and record the earthquake, earthquake waves. Seismographs are the instruments which detect and record the earthquake waves. Here is the figure which is showing the seismograph. Okay, so seismograph are the instrument which is used to detect and record the seismic waves. Most seismographs contains a heavy weight suspended from the up, suspended from the support which is attached to the bedrock. Here in the figure you can see that the heavy weight is suspended from the support. Heavy weight is suspended from the support which is attached to the bedrock. Okay, and in the figure you can see when the waves of the from the distant earthquake reach this instrument, the inertia of the weight keeps it stationary while the earth and the support vibrates. The moment of the earth in relation to the stationary weight is recorded on this recording drum. Okay, the movement of the earth in relation to the stationary weight is recorded on his recording drum. Okay, the some seismographs detect the horizontal motion while the others detect the vertical motion. Okay, and the trace of this earthquake waves is generally recorded traveling photographic paper. Here, the photographic paper is attached on this recording drum. Okay, and then these waves are recorded on the traveling photographic paper as the series of the zigzag lines. Okay, so the zigzag lines indicating the seismograph. The P and S waves are recorded, and P waves, S waves, and the L waves are recorded with these seismographs. Okay, and with the help of the seismograph, the intensity of this earthquake is identified. Okay, our next point is the origin of the earthquake. Origin of the earthquake. The tectonic earthquakes are most common and they are therefore most important. Okay, the earthquake is classified into two types, many types. This is we are going to study in the next slide. But in the main two types are the of this earthquake are the tectonic earthquake and the non-tectonic earthquake. So the tectonic earthquakes are very common and they are most important. The forces that causes the tectonic earthquake are the some which are causing the faulting and produce mountains on the earth surface. Okay, the possible mechanism of this tectonic earthquake can be explained by this elastic rebound theory. Okay, from this elastic rebound theory, the origin of the earthquake is explained in this theory. So first we will see this elastic rebound theory. In the figure you can see the here A figure indicating the no stress condition, whereas B showing the elastic strain stopped under the stresses, and third figure showing the release of the elastic strain. Means what? In the certain zones of the earth crust, the stresses accumulated gradually in the rock masses. So here in the figure 1 you can see the here is no any stress is there, but in this figure 2 you can see that the stresses are accumulated gradually in the rock masses. Okay, the stresses, that is elastic strain, is recorded or stored and under the stress. Okay, then when the stresses exceed the elastic limit of the rock, then they bend and crack. Okay, so when these stresses exceeds their elastic limit, then they bend and the crack. In the figure you can see, they are in the figure 2 you can see the stresses due to the due to when the stresses are exceed their elastic limit, the bend is the the rock masses are bent, and also in the third figure you can see they are cracked. So the seepage along the fracture is initially prevented by the friction. So under this condition, the rock will store up of energy and as an elastic stream. Some slight movement along the fracture plane produces the foreshocks. Okay, when the strain here in the figure see you can in the figures you can see there, when the strain reaches the critical point, the friction is overcome and the seepage takes place. The fractured block snap back to its original shape, thereby releasing the store of energy in the form of the earthquake by vibrating back and forth. Okay, so this is the springing back of this rock is called as an elastic rebound. Okay, the springing back of this rock is called as an elastic rebound. Some adjustment along this fault zone after the main earthquake produces the aftershocks. Okay, so this three figure showing the elastic rebound theory. Okay, this theory was put forward by the H.F. Reid. Okay, the next point is the earthquake intensity scale. Generally, the effects of an earthquake are strongest near the epicenter and it is decreases gradually outwards. Okay, so the two commonly used intensity scale are the Rossy-Forel scale and the Richter scale. Okay, these two scales are used to calculate the intensity of this earthquake. Okay, that means to have an idea about the intensity of the earthquake in the different regions, the intensity scales have been derived. Okay, and these are the two commonly used intensity scales are the Rossy-Forel scale and the Richter scale. So first is as a Rossy-Forel scale. The earthquake intensity scale, which is derived by the Rossy-Forel, is based on how people behave. Okay, so Rossy-Forel intensity is the earthquake intensity scale, which is derived by this Rossy-Forel, is based on how people behave and react, and also how much destruction or the disturbance is caused to the man-made structures and the natural objects. Okay, so the Rossy-Forel scale is based on how people behave and react, and also how much destruction or the disturbance is caused to the man-made structures and the natural objects. Okay, this Rossy-Forel scale is divided into 9 divisions. Okay, so the intensity 1 is given to the weakest earthquake, okay, which is felt only by some very sensitive people at rest. Okay, so the intensity 1 is given to the weakest earthquake, which is felt only by very sensitive people at rest, whereas the highest number, that is the 9 number, is assigned to the strongest earthquake that cause massive destruction to the man-made structures or natural objects. So and the any intensity which is above the fourth can causes the damage of the to the property. Okay, so this is the Rossy-Forel scale, which is divided into the 9 division. The first division is given to the weakest earthquake, while as the 9 division showing the strongest earthquake. Okay, and above above the force, uh, the intensity which is above force can causes the damage to the property. Okay, so this is all about the Rossi Foral scale. Next is the Richter scale. Richter scale. This intensity scale was derived by the Charles E. Richter. Okay. This Richter intensity scale, in the figure, in this table you can see that the Richter scale is given. This scale is this scale was devised by the Charles F. Richter, okay, which is an American seismologist. The American seismologist Charles A. Uh, Richter, okay, is devised this earthquake intensity scale. Okay, and this scale is based on the total amount of energy which is released during the earthquake. So the Richter scale is based on the total amount of energy which is released during an earthquake. So the magnitude is calculated mathematically using the amount and the duration of the ground vibrations, which is recorded by the seismogram. So here in the table you can see the magnitude 2.5. When the magnitude is 2.5, the effects will occur as uh, generally not felt or not recorded. Okay, when the magnitude is 2.5, the effect will be a local damage. When the magnitude is 6, the effect will be can be destructive in the populous region. Okay, so this is our, and when the magnitude is more than 8, the great earthquake or the total total destruction. So this effect are caused when the magnitude is greater than 8. Okay. This Richter scale is widely used to describe the magnitude of the earthquake. Okay. After that, after some year, an intensity scale, which is this intensity scale is modified by the Mercallis. Okay. This Richter scale is after some time it is modified by the Mercallis. So we will see here in the table which is showing the Mercallis scale. Okay, they have the Richter scale is modified by the Mercalli. So this Mercalli scale is divided into the 12 regions, 12 parts. Okay, when the intensity is divided into 12 divisions, and according to which they have given the effects. Okay, when the intensity is 1, that is the instrumental. When that means the acceleration is less than 1 centimeter, then the effects are only recorded by the instrument only. Okay, that is the vibrations only recorded by the instrument, that is not felt by the people. Okay, and then when the intensity is very strong, that is the acceleration over 50 centimeter, then the effect will be average home slightly damaged. Means when the intensity showing in the 7 unit, that time the effect will be what some homes are damaged. Okay, so this is as a Mercalli scale. Okay, our next point is the classification and the causes of the earthquake. Okay, based on the depth of the origin, okay, the earthquakes are classified into 3 types. First is as an shallow, second is as intermediate, and third is as an deep. Okay, so first is the shallow earthquake. Shallow earthquake means what? If the depth is more than 60 kilometer, but mm, sorry, when the depth of the earthquake, that is earthquake with the focus depth less than 60 kilometer, then it is called as an shallow earthquake. Okay, whereas when the depth is more than 60 kilometer but less than the 300 kilometer, then they are called as an intermediate here, uh, intermediate earthquake. Okay, means what? The focus is lying in between up to the 60 kilometer, then it is called as an shallow earthquake. Okay, when this focus is lying in between the 60 to 300 kilometer, then the earthquake is called as an intermediate earthquake, where the where when if the depth is the focus depth is more than the 300 kilometer, then it is called as a deep earthquake. Okay, so depending upon the depth of the origin, the earthquakes are divided into three types: shallow, intermediate, and deep. Okay, then, depending upon or based upon the causes which are responsible for their occurrence, the earthquakes are divided into two types: tectonic earthquakes and the non-tectonic earthquakes. Okay, so tectonic earthquakes are due to the internal causes. Here means depending upon the cause which is responsible for their occurrence also, the the earthquake are classified into two types: tectonic earthquake and non-tectonic earthquake. So the tectonic earthquakes are exclusively due to the internal causes. Means what? That is due to the disturbance or the adjustment of the geological formations which are taking place in the earth interior. Tectonic earthquakes are due to the internal causes. Means what? Due to the disturbance or the adjustment of the geological formations which are taking place in the earth interior. Okay, that means they are generally very they are very less frequent and more intense. Okay, so these tectonic earthquakes are more destructive in nature. Okay, these are the tectonic earthquake, and second is the non-tectonic earthquake. The non-tectonic earthquake, on the other hand, are generally due to the external or the superficial causes. Tectonic earthquakes are due to the internal causes, whereas non-tectonic earthquakes are due to the external or the superficial causes. Okay, so this type of the earthquake is very frequent. Okay, and minor or the minor, if they have minor in intensity, okay, they are so hence generally non-destructive in nature. Tectonic earthquakes are destructive in nature, whereas non-tectonic earthquakes are non-destructive in nature. Tectonic earthquakes are due to the internal causes, whereas non-tectonic earthquakes are due to the external or the superficial causes. For example, these causes are due to the huge waterfalls, due to the meteorites, due to the occurrence of the sudden and the major landslides, due to the volcanic eruption, due to the man-made explosions, and due to the dams and the reservoirs. All these are the causes of the earthquake. Okay. Means what? Due to first is the due to the huge waterfalls. Means what? When the huge quantities of the water found a particular place, then tremors develop in the ground surface. Okay, and this due to which the earthquake occurs. Tremors are developed due to this huge quantity of the of water which is found on the particular place. And then due to the volcanic eruptions, means what, some volcanoes like Stromboli, which is occurs in the Italy, which erupt calmly without any fear and quietly pour out the lava. Okay, and due to this also, the means due to the volcanic eruptions, the earthquake occurs, because when the during this volcanic eruption, they erupt a very uh, thunderous noise. Okay, this eruptions is violently with a thunderous noise, throwing out the fire, smoke, pyroclast to the great heights, and accompanying the terrific blow up of this crater. And this is particularly so in the Pelian type of the volcanoes. Okay, so the volcanic eruptions also responsible for the earthquake. Then, due to the man-made explosions, means during the mining of the economic minerals deposits and during the quarrying of the building materials, many explosions are carried out, and due to this, they produce a tremors locally. Okay, so the man-made explosions are also responsible for the small responsible for the earthquake, but their intensity is very much low. And recently, the dams or the reservoirs are also uh, responsible for the earthquake, because when the reservoir area, which is an seismic, started showing the signs of the earthquake occurrence. Why? When this water is filled with the water, they may due to this they may due to the earthquake is made due to the great lateral thrust of the reservoir water, which is contributing to the stress imbalances, are due to the reactivation of the subterranean faults by the newly developed stresses, or it occurs sometimes due to the increased pore pressure in the adjoining rocks. Okay, so the dams and the reservoirs also show the regions which are the reservoir areas which were seismic started showing the signs of the earthquake occurrence when they are filled with the water. Okay, so all these are the causes of the earthquake. Next is the effects of the earthquake. The effect of the earthquake is divided into the two types. First is as an primary effect, and second is as an secondary effect. The primary effects are related to the cause of the origin of the earthquake. Means these include all such effects that are directly related to the cause of the origin of an earthquake. The tectonic earthquakes are often responsible for producing the important changes in the geological structure of an area. The changes occurs like creation of the slopes, then fissures, wrapping of the strata, immersions or the subsidence of the coastal lines, changes in the sources in the courses of the streams, origin of the new springs, certain creation of the sand dikes. Okay, so all these are happened uh, happened due to the uh, earthquake. Okay, and these are related to the origin. All these changes occurs in the earth surface due to the uh, earthquake. Okay, so the effects which are caused due to the that is the causes which are related to the origin of the earthquake are the primary effects. So the effects which are related to the cause of the origin of an earthquake are called as in primary effects. Now we will see the secondary effects. Secondary effects means all those effects which are related to the passage of the seismic waves and their associated shaking motion of the ground during an earthquake are called as an secondary effect. Okay, the secondary effects are observed in the construction of all the types of the buildings. Means the secondary effects are observed in all the types of the constructions. Many landslides are triggered mainly due to the shaking vibrations rather than their actual rupture. Okay. So due to these vibrations, buildings, bridges, dams, poles, posts, fences may be slightly or heavily damaged. Okay, so these are all are the secondary effects. The telephonic, electric cables, water pipeline may get broken. Huge waves may be caused in the sea water. That is called as a tsunami. The tsunami occurs. So tsunami is also included in the secondary effects. Huge waves are generated in the sea water. Okay, and these are called as tsunamis. Okay, the height of the tsunami is 2 meter or more sometimes. Okay, so this is also the secondary effect. The trees may get uprooted. Okay, their trunks and branches may get twisted and broken. This is also the secondary effect. Also, the animals of all the types are seem to be react differently or abnormally during an earthquake. They are going here and there. The horses may get started snorting or bolting. Okay, dogs start barking. Okay, uh, then also the human reaction towards earthquake is most typical. uh, some people experience or feeling like a panic. Okay, then this is the all are the secondary effects. Our next point is the earthquake zones in the India. The Geological Survey of the India, that is GSI, is first published in the seismic zoning map of the country in the year 1935, and such a map is initially based on the amount of damage which is suffered by the different regions of the India because of the earthquake. So here is the figure which is showing the different regions of the India, uh, which is damaged or is suffered by the earthquake. Okay, so the zone 2 showing showing that the low risk zone 2 is said to be a least active, or it is a low risk zone. Okay, the zone 2 covers the part of the eastern Maharashtra, Karnataka, Chandigarh, Andhra Pradesh, Tamil Nadu, Madhya Pradesh and Rajasthan. Okay, this part is said to be as a least active. Okay, zone 2 is least active. Okay, next is the zone 3. Zone 3 is said to be a moderate seismic zone. Zone 3 is said to be a moderate risk zone. Okay, so initially whole Maharashtra was considered to be a least active, but after the Latur means Killari earthquake struck, it is included in the moderate seismic zone. In present seismic map, part of the Maharashtra, Gujarat, West Bengal, then Kerala, Punjab, Uttar Pradesh are classified in the zone 3. The Andaman and Nicobar Island, some part of the Kashmir, Western Himalayas fall under this zone 3. The IS code assign the zone factor as 0.16 for this zone 3. Okay, So this is all about the zone 3. Next zone is the zone 4. This zone is high seismic zone. Zone 4 is high rig zone or the high seismic zone. It covers a part of the Indian capital, that is Delhi, Bihar, Uttarakhand, Jammu Kashmir, Sikkim. All this part is included in the high seismic zone. A small part of the western Maharashtra, that is Konkan, are also included in the high seismic zone, that is in the zone 4, some part of the Maharashtra. Okay. Then the IS code assigned the zone factor as 0.24 for this zone 4. For the zone 2, the zone factor is 0.10. For the zone 3, the zone factor is 0.16, and for the zone 4, the zone factor is 0.24. Okay, and next zone is the highest seismic zone, that is the zone 5. Zone 5 indicating the or said to be as an highest seismic zone. It covers the whole Arunachal Pradesh, Assam, Nagaland, Manipur, Mizoram, Meghalaya, then Tripura, part of the western Gujarat, Uttarakhand, Bihar, and the Himachal Pradesh. Okay, so in these all parts are included in the parts of the India are included in the zone 5th, which is the highest seismic zone. The zone factor assigned by the IS code is 0.36 for this zone 5. The structural designer used this factor for the earthquake resistant design of the structures in the zone 5. So in the figure you can see the different colors are given, okay, for different zones. Zone blue indicating the zone 2, yellow indicating the zone 3, okay, red indicating the zone 5. Okay, so according to the intensity, uh, the India is divided into the different zones. Our next point is the earthquake resistant structures. Earthquake resistant structures means what? If we for to minimize the effect of the earthquake, we have to taken some precautionary measures while the construction of the different buildings. Okay, while the construction of any type of the structure. First, we will see the precautionary measures which are taken at the time of the construction of the building. Okay, so all these precautionary measures are divided into the different guidelines, and these guidelines are summarized below. So for summarized in the different points, in that is the foundation, body, roof, and general. So first we will see the guidelines for the foundations. First guideline is the structures built on the loose soil or the sediments or the weak rocks will have to withstand the greater risks compared to those founded on the solid bedrock in the same region, the other things being the same. So this is the primarily due to the fact that the soil particles undergo a lot of compaction during the seismic shocks, thereby causing the settlement. So while the construction of the foundation for the concrete and the masonry building should be excavated to the some level throughout the building, and it should be as far as possible of continuous type. Okay, all these masonry buildings or the foundation of the concrete should be excavated at some depth. Okay, and all these excavation should be continuous type. Then second point is second the guidelines. Now we will see the guidelines for the body. The wall should be, unless properly designed, the walls should be properly designed. That is, for the continuity of the cross wall should be maintained as far as possible. The in the masonry walls, the keys should be inserted in the proper style. Okay, so these are the guidelines for the while the construction of the body of that building. Then the third point is the roof. The RCC roof give the better resistance against the shocks compared to the sloping roofs or those designed with the different slope angles. So the RCC roof should be preferred for the earthquake resistant structures. Then the projections above or beyond the roof level, such as chimney, should be altogether avoided. That is, the chimney should be avoided or kept to the minimum. And general guidelines are all the parts of the same building, that is the foundation, superstructure, roof, should be firmly tied together. Okay, the uniform height should be given to the structures. So these precautionary measures are taken into account while the construction of the building. Now we will see the guidelines or the general consideration for the dams, quake resistance dam. So first guideline is dam should be designed in a seismic region in such a way that during an earthquake they move along with the foundation below. Okay, and the abutments on the sides as an integral part of the country rock. Then, as far as possible, the dam should not be placed along, across, or in the close vicinity of active faults. Okay, so the dam should not be placed along or across or in a close vicinity of an active fault. Okay, so these are the guidelines which are taken into account while in the construction of the dams. Okay, so in this lecture we have seen the we have studied the earthquake. In that we have seen the classification of the earthquake, then the different terms related to the earthquake, then the intensity of the earthquake, then the magnitude of the earthquake, causes of the earthquake, then the effects which are caused due to the earthquake, the classification, also the different earthquake zones in India. All these points we have studied in this lecture. Okay, hope you have understand all these points well. Thank you.